Okay, dear students. So let's resume our class. Wherever we concluded yesterday on complex numbers. So today, what we are going to discuss is that algebra of complex numbers. First, we'll start with algebra of complex numbers. Um, then we proceed with the other relevant topics. So, in the algebra of complex number, dear students, the first, what we are going to learn is that addition of, you know, addition of two complex number. Okay. So, for the addition of two complex number, how we are going to proceed, dear students? So, let's Z1 and Z2 be two complex numbers. Z1 and Z2 be two complex number. And the way we represent complex number, as Z1 plus Z2. So Z1 we can represent as A1 plus IB1, and Z2 is equal to A2 plus IB2. This is the way we can represent, the two complex numbers Z1 and Z2, as you see, dear students. Then, what is Z1 plus Z2? Z1 plus Z2 is a complex number where we add the real part. So real part of Z1 is A1 and real part of Z2 is A2. So we are adding A1 plus A2. That becomes the real part of the complex number Z1 plus Z2. And we add the imaginary part of Z1, that is B1, and imaginary part of Z2, that is B2. So we add B1 plus B2. That becomes the imaginary part of Z1 plus Z2. So in simple terms, is that the addition of two complex number, if we add, then the real part of that resultant complex number, which is the addition of these two complex number, is the addition of the real parts of the individual complex numbers which have been added. And the imaginary part of the resultant complex number is the addition of the imaginary part of the the individual complex number. So in this case, we discussed with two complex numbers Z1 and Z2. As you see that Z1 plus Z2 is equal to A1 plus A2, which is the addition of the the real part of the two complex numbers Z1 and Z2, and B1 plus B2 is the addition of the imaginary part of the two complex number Z1 and Z2. So we see that Z1 plus Z2 is a complex number with real part as A1 plus A2 and complex part as an imaginary part. I should say it is not complex part, it is imaginary part as B1 plus B2. Is okay, before I proceed further, could you please confirm that you are able to hear my voice very clearly and able to view the content very clearly?
Yes.
Yes.
Okay, great. Thank you very much for your confirmation. Okay. Now, what we are going to discuss about the the difference of two complex numbers. Dear students, to discuss about the difference of two complex numbers, the fundamental thing what we can say is that Z1 minus Z2, that we are going to discuss. So that how we can write, that we can write is that Z1 plus of minus 1 into Z2. That means as if that we are adding two complex numbers. Okay. One is that one complex number is Z1 and the other complex number is minus Z2. Okay, so let me show it to you, then you will come to know that exactly what I am talking about. So I'm going to a new page. Yeah. So as you see, dear students, so difference of two complex numbers. So let Z1 and Z2 be two complex numbers so that Z1 is equal to A1 plus IB1 and Z2 is equal to A2 plus IB2, the way we represent complex numbers. Then the difference between the complex numbers Z1 and Z2 is denoted by Z1 minus Z2 and is defined as Z1 minus Z2, as I was telling, is equal to Z1 plus of minus Z2. That means as if you are, multiplying that each, both the real part and the imaginary part of Z2 by minus 1. That means what we are going to get here is that it is like this, A1 plus IB1 minus A2 minus IB2. Correct, dear students? And after that, what we are doing, we are actually joining, making that real part together and imaginary part together. If we make real part together, then we are getting it is A1 minus A2. And the imaginary part together, then we are getting B1 minus B2. So what we see is that Z1 minus Z2 is a complex number with real part as A1 minus A2 and imaginary part as B1 minus B2. So this is the way we perform the difference of the two complex numbers. Dear students, the way we have learned so far is that any number system, we perform the algebraic operation, addition, then subtraction, then multiplication, then division. The next point what we are going to discuss is the multiplication of two complex number. Now how to perform the multiplication of two complex number, that we are going to discuss now. And as I always say, dear students, any confusion, any clarification at any point, never hesitate to let me know. So multiplication of two complex numbers. So let us take two complex numbers Z1 and Z2. Z1 is equal to A1 plus IB1 and Z2 is equal to A2 plus IB2. Just to make sure that you are all aware, but I'm just repeating the statement. A1, B1, A2, B2, all are real numbers. They all belongs to the set of real numbers. So I'm just as we started discussing complex numbers since in the yesterday. So here A1, B1, A2 and B2 all belongs to the set of real numbers. And we know I is equal to square root of minus 1. All these things we have learned yesterday. Now Z1 is equal to A1 plus IB1, Z2 equal to A2 plus IB2. Then how we are performing Z1 into Z2? So dear students, so this is the representation of Z1 into Z2, and what we are doing, we are actually applying the distributive law, if you see. So A1 into A2 plus IB2 plus IB1 into A2 plus IB2 means if I write more elaborative manner, it becomes A1 into A2 plus IB2 plus I into B1 A2 plus IB2. Now dear students, you multiply A1 A2, then I into A1 into B2 plus I into B1 into A2 plus I into I, that is I square, B1 into B2. That's we get the next step. After that, let's calculate a little bit. We know what is I square, dear students. I square is equal to minus 1. As I is equal to square root of minus 1, then from here what we can say? From here we can say that I square is equal to, this implies I square should be equal to minus 1. And that's what we wrote. Instead of I square B1 B2, we wrote minus B1 B2. So this is the step we get. After that, what we did is that we actually clubbed this, the real part together and club the imaginary part together. So if we club the real part together, we get A1 A2 minus B1 B2. And if we club the imaginary part together, what we are getting is that A1 B2 plus B1 A2. So what we see, dear students, is that if Z1 and Z2 are two complex numbers, then Z1 into Z2 is also a complex number with real part as A1 A2 minus B1 B2 and imaginary part as A1 B2 plus B1 A2. Okay, so this is the way we perform the multiplication of two complex numbers. So what you see, dear students, so far in the addition and the difference and the multiplication, when we have two complex number and after the result, that is the result of the addition, result of the subtraction, result of the multiplication, always we represent that complex number in the form of, a plus ib format. That means a real number plus I into another real number. So what I wanted to mean, dear students, if I just summarize about the addition, subtraction and difference, is that suppose you have z1 is a complex number and you are having a operator star z2 is a complex number. Then what we are going to get? So this star could be, if I use a different color, this star could be either plus or minus or multiplication. Okay, so what we are going to get out of it, that whatever we are getting here, so that we are representing first the real part plus I into imaginary part. So this is also a real number. So suppose if I write this as p and this is q, p is a real number, correct, my dear students? So this is a real number and q is also a real number. So why I'm saying so? I'm saying so that whenever it is a complex number, the best way to represent is that it is in the form of a plus ib, which I wrote is a p plus iq in this one. So now, if we concentrate on the next operation, that is the division of two complex numbers, how we are going to perform? That is quite obvious. That how we are going to perform the division operator. So for example, I'm not sharing the entire thing. I'm just sharing that the partial information here, as long as the partial note here, as long as the division of two complex numbers is concerned. For example, dear students, if you see that z1 and z2 be two complex numbers, so that z1 is equal to a1 plus ib1 and z2 equal to a2 plus ib2. And we know that whenever we perform a division, the denominator should not be equal to 0. So z2 should not be equal to 0. Then how we are going to perform z1 by z2? Now what we just learned few minutes back is that whatever z1 by z2 is, that we need to represent it in the form of a plus ib. That means a real number plus I into another real number. How we are going to do this thing? Here we're going to just apply the concept what we did in case of an, you remember dear student, irrational number. When we get a denominator irrational number, what we do the rationalization, correct or not? For example, if I tell you that okay, simplify 1 by square root of 3 plus square root of 2, generally what we do, we multiply both numerator and denominator by square root of 3 minus square root of 2, correct or not? Square root of 3 plus square root of 2 into square root of 3 minus square root of 2. So then what we get is that we get square root of 3 minus square root of 2. In the denominator we get square root of 3 whole square, that is 3, and square root of 2 whole square, that is 2. So what we get, root 3 minus root 2, and that is more representable format. As you remember, we discussed earlier that always we try to represent a number which is in the denominator there is no irrational number. We are going to apply the similar concept here. Okay, what is the similar concept here, dear students, is that we will multiply both numerator and denominator by a2 minus ib2. And a2 minus ib2 is a proper naming for that. It's called the conjugate of a complex number a2 plus ib2. What does it mean? It means is that if we have a complex number a plus ib, its conjugate will be what, dear students? A minus ib. That is called conjugate complex number. We will discuss all these things in details, but this is the terminology, and for that no extra information is required. That's why I define it. It's conjugate. So if I write it properly, if you do not see it very clearly, conjugate. conjugate of this complex number a plus ib is a minus ib. Then what we are going to do, dear students, that we are going to multiply both numerator and denominator by a2 minus ib2. Now, if we do this thing, then what we are going to get? We are going to get something you must be very familiar with. Okay. If it is not, never hesitate to let me know that if you are not familiar with it. So what we are going to get, dear students, is something like this, that a1 plus ib1 into a2 minus ib2 divided by a2 plus ib2 into a2 minus ib2. This is the step we get, dear students. After that, what we do is that we are multiplying. We know how to multiply two complex numbers. That's what we have performed in the numerator. And in the denominator, dear students, what we get? a2 square plus a2 square minus ib2 square. If you look into this particular portion, that this denominator, only if you concentrate on the denominator, what you are going to get, dear students, you are going to get something like this. If I write here is that a2 square minus ib2 square. That's what we know now, a plus b into a minus b. So that is equal to a2 square minus I square b2 square. I square equal to what? I square equal to minus 1. So a2 square minus of minus 1, that is plus 1. So a2 square plus b2 square. And that's what we have written it here. So what we get, dear students, that in this step, what we get is that a1 a2 plus b1 b2 plus I into a2 b1 minus a1 b2 by a2 square plus b2 square. After that, what we do? After that, we divide both the two expressions in the numerator by a2 square plus b2 square. Why so? Because this is a real number, a2 square plus b2 square. In these steps, what we have achieved, dear students, what we have achieved is that in the denominator, initially in the denominator, there is a complex number. That means there is a imaginary part. Okay, it is not a purely real number. But what we did, in these two steps is that we make the denominator is a purely real number. Okay, and why it is so? That is going to give us the advantage in the next step. So we are dividing that a1 a2 plus b1 b2 by a2 square plus b2 square, and a2 b1 minus a1 b2 by a2 square plus b2 square. So then what we are going to get? z1 by z2 is this is a real number plus I into this is another real number. So it is in the form of a plus ib, right? So to achieve this, we have performed this one. So dear students, whenever there is a question comes in the exam, that whenever you get a complex number in which is not given in a very in a plus ib form directly, and you need to find the you need to express in the form of a plus ib, then you need to perform this step. What is that step? That is the denominator. You should multiply that complex number with its conjugate. Conjugate is a term, but in a very simple way, what you can see is that if 3 plus 2i is a complex number, its conjugate is 3 minus 2i. If minus 5 plus 7i is a complex number, its conjugate is minus 5 minus 7i. And the converse is also true. Means if a minus ib is a complex number, its conjugate is a plus ib. So these are the steps to find. So for example, it could be a question like this: find the a real part of the complex number 3 plus 2i by 7 minus 9i. 7 minus 9i. Find the real part of this complex number. So what will be the steps? Steps will be that multiply both numerator and denominator by 7 plus 9i. After that, you perform whatever the operations I explained here, and then make the real part separate and imaginary part separate. Then real part you actually show that this is my answer. Okay, these are the steps you must be following. So that when we need to find the division of the complex numbers. So now, dear students, I am going to explain you a very important part here is that power of I. That how to find the power of I. The power of I is a very important topic, and this is going to be helpful in many questions moving forward. And hence, you must be having a very clear idea about power of I. So what happened is that you can do it by your own also, but my task is to just make it in the simplified form. What is I, dear students? If you see, I is equal to what, dear students? I is equal to square root of minus 1. That we all are aware of. So from here, what we can say? From here, we can say I square is equal to what? Minus 1. From here, what we can say? I cube is equal to what? Minus I. What we can say? I power 4 is equal to, again it becomes minus I is whole, minus I into I. So it becomes plus 1. I hope all of you agree to it. If I is equal to square root of minus 1, then I square is equal to minus 1. I cube equal to minus I power 4 is equal to 1. Then what we are going to get here, dear students, is that I power 4k. I hope all of you agree to me that I power 4k should be equal to I, correct or not? And why I power 4k should be equal to I? Let's concentrate on I power 4k. So what is I power 4k? I power 4k is equal to, we know from the laws of indices, it is I power 4 power k. Correct, not dear students? And we just found that I power 4 is equal to 1. Correct or not? So as we found that I power 4 is equal to 1, then what we can say is that it is 1 to the power k. 1 to the power k is equal to, it is 1. Correct or not? Now, let's look into the next part, that I power 4k plus 1, that should be equal to I. Why? Because it is quite simple logic. I power 4k plus 1, that is equal to I power 4k into I power 1. I power 4k, we just found the value is a 1. So 1 into I power 1 is I. So that is equal to I. Then the next one, what we are getting is that I power 4k plus 2. So I power 4k plus 2, that is equal to I power 4k into I power 2. What is the value of I power 4k, dear students? We found it out, that is equal to 1. And what is the value of I square, dear students? Initially we found it out, I square equal to minus 1. So 1 into minus 1, that is equal to minus 1. And the next one is that I power 4k plus 3. I power 4k plus 3, that is equal to what? That is equal to I power 4k into I power 3. What is the value of I power 4k, dear students? Is 1. And I power 3, we just found it out, is minus I. So that is equal to minus I. So whenever you get this kind of questions, so always it is important to remember that how we can apply the concepts of the different power, different power in a very efficient manner. And I'm just going to show you a couple of examples, so it will help you to understand that how this knowledge is going to help us to solve, problems. Okay, so I'm going to give you an example. Just give me a minute. Let me find this one, and I'm going to give it to you, and all of us will do together. Okay. The question will be available to you, dear students, in few seconds. We can do it here itself. And let us all of us do together, okay? And this question came in one of the previous year, The question here is that the smallest possible integer n for which 1 plus I by 1 minus I power n is equal to 1 is what? That we are going to find. All of you can, start doing along with me. So how to find that one? Okay. So, if someone able to find the answer before me, then you can let me know. So 1 plus I, in the question, the bracket is little small size. So 1 minus I, so bracket should be like this, power n. It is small, na? So consider the bracket is something like this and power n. That is equal to 1. To solve this kind of problem, dear students, as we just learned few minutes back, that denominator, what is 1 minus I, we should multiply with its conjugate. What is the conjugate, dear students? It is 1 plus I. So from here, what we can write is that, dear students, is that we can write something like this. 1 plus I and 1 plus I, because we are multiplying both numerator and denominator by the conjugate of the complex number 1 minus I, and the conjugate of 1 minus I is 1 plus I. I hope all of you agree to me. Always perform this step. Whenever you get a complex number in which the denominator is a complex number, means z1 by z2 form, then your first task should be to multiply both numerator and denominator of that complex number by the conjugate of the denominator of the complex number. What we have done it here. Then what we are going to get out of it? So from here, what we get is that 1 plus I whole square divided by 1 square minus I square. Correct or not, dear students? Power n is equal to 1. Correct or not? So after that, I am coming here. So this implies 1 plus I whole square. So let us do it. 1 plus I whole square is what? 1 square plus I square plus 2 into 1 into I divided by 1 square is 1 and I square is equal to minus 1. So minus of minus 1. I'm writing in elaborately as we have started learning this topic. That is equal to 1. As time goes by, you will get more confident. So then what we are going to get in the numerator? I square is 1. 1 square is 1. I square is equal to minus 1 plus 2I divided by 1 minus minus I. That is equal to what? It is 2. So this complete power n is equal to 1. That implies what? 2I by 2 it got cancelled. I power n is equal to 1. So what will be the value of n, dear students? N should be equal to 4. That is the least possible value. Okay. If n equal to 4, then you get n equal to 4 is the least possible value of n. For that, I power n is equal to 1. Now, more than 4, there are also an answer. For example, if you get it 8, then also you get 1. But point is not that. Point is that, you need to find the value, you need to find the value of n which is the least one. That's what it is asked here. The smallest positive integer n for which this is equal to 1. So from here, we can say n equal to 4 is the least positive integer, is the least positive integer, so that we get, that 1 plus I by 1 minus I power n equal to 1. And what we get the none of this as the correct answer, dear students. Okay, so what we get, none of this as a correct answer. So like this, so you see in this example, what we have done, we have, we understood the significance of applying these concepts. Okay, now another problem we can do. Okay, so this problem, you will also see that how these concepts are being applied very effectively. And this is the, question. The question will be available to you in the another few seconds, dear students. Here it is. So let me bring this question in the new page. Okay. So this question came in one of the previous year in one of the engineering entrance examination. What is the question here, dear students? Is that, the value of the sum n equal to 1 to 13 I power n plus I power n plus 1, where I is equal to square root of minus 1. Okay. Now, how you can do it? So there are multiple ways you can solve this problem. So you can let me know. I give you a couple of minutes. Please work on it, and then do let me know what is the solution we are getting. Okay, please take a couple of minutes and solve this problem. Here you can use the concept of sequences and series as well. And other concepts also. Anyone got it, dear students? I can give you little hints here. There are two ways you can approach that. We just learned is that, I square is equal to what? We learned I square is equal to minus 1. Then what we learned, I cube is equal to what? Minus I. And I power 4 is equal to 1. Now, if you apply all these things together, then what you are going to get? I plus I square plus I cube plus I power 4, that is actually become 0. Correct, not dear students? Do you agree to me? Because I is I, then I square is minus 1, then I cube is minus I, and I power 4 is 1. So if you add all these things, you will get actually 0. You can leverage that information to solve this problem. So how we are going to do it? Okay. So then from this particular, so whatever is given is that if someone is able to find the solution, you can let me know, dear students. Okay, n equal to 1 to 13. So I power n plus I power n plus 1. So that we can break it from the sequence and series in discussion. We know that we are aware of this big sigma notation. So that is equal to 1 to 13 plus summation I power n plus 1 n equal to 1 to 13. Now if you see, dear students, that I n equal to 1 to 13 I power n, how we are going to compute it? We are going to compute it in that I power 1 plus I power 2 plus I power 3 plus I power 4. Correct? that is equal to 0. Then I power 5 plus I power 6 plus I power 7 plus I power 8, that is also 0. So if you make a club of this 4, 4, then what will happen? Then till I power 12, you will get, it is 0. I hope you are getting my point, dear students. So what I wanted to mean is that first you get I plus I square. So just a minute. I'm just concentrating on this particular one. This particular one I'm going to concentrate. So what I'm going to get? So it is like that I plus I square plus I cube plus I power 4 that we can club together, plus I power 5 plus I power 6 plus I power 7 plus I power 8 plus I power 9 plus I power 10 plus I power 11 plus I power 12, these 4 club together, plus I power 13. Explicitly if I write this is, now this is what? This is nothing but 0. This is what? This is also 0. How come you know? Because you can take I power 4 common. I power 4 if you take common, then what you will get? I plus I square plus I cube plus I power 4. That becomes 0. And here also you can take what common? I power 8 you can take common, dear students. So then what you will get? I plus I square plus I cube plus I power 4. So that is also getting 0. And I power 13. So finally this value is actually I power 13. Correct or not? So now what I can write here is that, so this we can write is that I power 13 plus sigma of I power n into I. So what I can write is that, this I can write is that I power n into I. So n equal to 1 to 13. Now dear students, is that I can take that I outside. So that means what? What I wanted to mean is that I can remove this I and I can bring that I outside. And we just learned that n equal to 1 to 13, I power n is equal to I power 13. So what we can write, that I into I power 13. So that is equal to, we can take I power 13 plus I power 14. I power 13 we can write I power 12 into I, and I power 14 I can write I power 12 into I square. Correct, not dear students? So I power 12 is equal to what? It is 1, because we remember the power of I power 4k, that I power anything multiple of 4 is equal to 1. So I, and here also we get I square. Now what is the value of I square? Value of I square is equal to -1. So we get I minus 1. In this way we are able to achieve this one. The same problem can be done in multiple ways. So I can do in another ways of the same problem. How? Let me show you. So let me use a different color so that you can make a difference later. So what is the sum here, dear students, is that summation of I power n plus I power n plus 1. And what we are going to get is that n is equal to 1 to 13. What we are going to do here, dear students, let us focus on what is there inside that summation. So inside that summation we can take I power n common. Then what we are going to get? We are going to get, it is 1 plus I, and n is equal to 1 to 13. And dear students, whatever is there 1 plus I, it is independent of n now. So we can take outside of that summation. So what I wanted to mean? I wanted to mean, one can write is that 1 plus I into summation of I power n is equal to 1 to 13. Now dear students, we can find the value of I power n from where n is equal to 1 to 13 using the method what we just learned, or also we can use the concept of loosely defined way of, we can use the concept of geometric progression. If you see, that I power n summation is in geometric progression where n is varying from 1 to 13. So if you recall that geometric progression rule, then 1 plus I into what you can write is that I into I power 13 minus 1 divided by I minus 1. Correct, no, dear students, if you apply the concept of geometric progression rule. And what is I power 13? I power 13 is nothing but I, because it is I power 12 into I. I power 12 is a multiple of 4. That power should be I. So what we get? We get is that I plus 1. 1 plus I, we can write as I plus 1. Then I minus 1. Then I into I minus 1 divided by I minus 1. So what we can do is that I minus 1 got cancelled. So what we get? I into I plus 1. So that is equal to I square plus I. I square is equal to minus 1. So minus 1 plus I, that is equal to I minus 1. We get the same result. Same problem we can do it in multiple ways. Correct, not dear students? So I hope it is clear. Let us do a couple of more problems so that next class what we are going to discuss is that we will discuss a fantastic concept of modulus of a complex number, argument or amplitude of a complex number. And before that, I will suggest you to look into some of my video lectures on inverse trigonometric function. That will be one task to you, given to you. Okay. I'll share those links to you that you need to look into those my video lectures of inverse trigonometric function. So that will give you a very clear idea when you are going to discuss tomorrow about the argument or amplitude of a complex number. But before that, dear students, let us solve a couple of more problems. Okay, and I want your involvement in solving this. Okay, so you see that whenever we discuss the laws of indices, how important it is, and it is actually playing a big role here in our calculation. So now, dear students, so next question what I'm going to give you is this one, and I appreciate if you all can do along with me. The question here is that for n belongs to z, that is a set of integers, the value of 2 power n by 1 plus I power 2n plus 1 plus I power 2n by 2 power n is what? That you need to find the value. So that out of these four options, which one is going to be correct? So please try. You take a couple of minutes, and then we will start discussing the solution to this question. And dear students, any doubt at any question, never hesitate to let me know. Please, never hesitate. Take a couple of minutes and solve it. Okay, dear students, so you can share your experience with me, how we are doing. So, and what is your result? So how you are going to perform this one? Nah? So the way to perform this one, dear students, so this entire expression, whatever has been given, is that we can write something like this, that 1 plus I power 2n, we can express like this, 1 plus I power 2 Correct, no? And whole power n. Correct or not? So what I wanted to mean is that, so this entire expression, let me write it down. Yeah. So this entire expression, that 1 plus I power 2n, that is our focus here. So 1 plus I power 2n, what we can write is that 1 plus I power 2 power n. So let's see what we are going to get out of it. Okay. So it will, you will get the finally you will get is that 1 plus I square plus 2I power 2n, 2I power n.
Sir, I'm getting the option C.
Correct, you are. Absolutely. Appreciate. It is indeed option C. Okay. All of you got option C? Okay. I gave this task to you. So I'm just giving you the hints. What you need to do is that whatever you see, dear students, that 1 plus I power 2n, that you need to express. Whatever you see, dear students, 1 plus I power 2n, that you need to express in the form of 1 plus I power 2 power n. Then 1 plus I power 2, you can express it. You will get 1 plus I square plus 2i. I square is minus 1. That will get cancelled. So you just need to think 1 or 2 steps ahead, that if I represent like this, what I'm going to get it. Okay. And then proceed. And you will find the option C as the correct answer. Now, meanwhile, I would, let me discuss another good question with you. And here is the question, and I want all of you to solve it. Yes, I hope all of you got the idea, right? So next question, what I'm going to give you is, this is the one. So the smallest positive integral value of n, so that 1 minus I by 1 plus I power n, so bracket is a little bigger, you can assume, is purely imaginary with positive imaginary part. One problem we have solved little bit like this in the today, that where it was equal to something. If you recall this question, yeah, 1 plus I by 1 minus I power n is equal to 1. What is the smallest positive integer n? In the similar concept, you need to apply here to solve this particular question. That 1 minus I by 1 plus I power n is going to be a purely imaginary with positive imaginary for what small positive integer value of n, that you need to find. And I appreciate if you can start solving it. And why you need to do it, because because I already showed you by one step that how you need to perform it. Okay, please go ahead. So first and foremost thing is that if you simplify 1 minus I by 1 plus I power n, what you will end up with, what you are going to get it, that you need to first find it out.
I got
Fantastic, Samir.
minus I to the
Appreciate.
power n.
That is actually we are 80% of the solution we have achieved the answer what you said. So the moment we come up to that simplification of that expression as minus I power n, then we are 80% of the solution, dear students. So I'm just sharing the solution with you, and I hope you understand each and every step here. You can take 1 minute to understand, or you can take your time. There's no hurry on that. Now we need to concentrate on that. What will be the value of n, means smallest positive integer of n, so that that value, that is minus 1 minus I power n, is going to be a purely imaginary with positive imaginary part. So now if we take n equal to 1, if we take, so here what you can take is that first you take n equal to 1. What we are going to get? We are going to get is that minus I power 1, that is equal to minus I. Minus I is a purely imaginary number, but imaginary part is not negative, no? Minus I is what? Minus I you can represent as 0 plus of minus I. Imaginary part is negative, no? Or we can write not in that manner. So we can write 0 minus I.
Yes.
That is not a purely imaginary number with a positive imaginary part. Here the negative. So n equal to, here it is a negative imaginary part. So n equal to 1 is not an acceptable answer. Now let's put n equal to 2. If you put n equal to 2, what you are going to get? Minus I power 2. That is minus 1 is minus I. I square is equal to what? We know I square is equal to minus 1. So what we are going to get? This is equal to minus 1. Now minus 1 is not a purely imaginary number. It is actually a purely real number. So n equal to 2 is not going to work. So n equal to 1 is not going to work. N equal to 2 is not going to work. Then let's apply n equal to 3. If we apply n equal to 3, dear students, so what we are going to get? N equal to 3. So minus I power 3. So that is equal to minus 1 power 3 into I power 3. Correct? Minus 1 power 3 is what? Minus 1. And I power 3, if you recall, dear students, today only we discussed, that is equal to minus I. So minus 1 into minus I, that is equal to I. And what is I? I is a purely imaginary number with positive imaginary part. So that we can write is equal to 0 plus I. So what we can say is that correct answer to this question is option B. Correct, dear students? So with this, yeah, all of you understood, right? Please confirm that Mohor, Disha, Srijita, Udhansu, all of you understood very well, dear students?
Yes. Yes.
Okay, great. So why I spend time in
Yes, sir.
solving these questions is that just with the fundamental information what we learned today, with this, how these questions can be answered with our knowledge of laws of indices and the power of I. This is also very important, power of I, what we discussed today. With this, dear students, I would like to conclude the class for today. But before that, before I conclude, so what I'll suggest you is that now time has come that you should solve, couple of, DPPs. So as you know, dear students, so you need to go to, I'm just writing it out in case, you are not able to remember. So you need to go to www.KonarClasses.com. After successful login, go for that write online examination. Then in the search, you can give the DPP. Okay, DPP set 1, DPP set 01 and set 02, that from complex number. This you need to complete before we start our class tomorrow. And what you need to do is that along with that, I'm going to share you the video lectures of mine on inverse trigonometric function. I will suggest you an inverse trigonometric function and trigonometric equations. First, I will send you trigonometric equations and then inverse trigonometric functions. What is your task now, dear students? No need to solve any problem. Just go through these video lectures. And you'll find it is very, very clear. In fact, I can tell you it is available in the online, test platform itself. So just a minute, let me stop sharing this one and let me share a new screen. So just to show you that how you able to view this thing. So let me stop presenting this one. Let me start sharing another website, that is that www.konarclasses.com, and I'm just going to show you how you can look into those video lectures. uh, you know so just can you please confirm that you are able to view this website?
Yes.
Okay, great. Then click onto the login. Then I'm just going to log in with a demo one. After that, what we'll do, dear students, so you need to come to the right practice test. Click into here, trigonometric equations, not functions. Okay, trigonometric equations. After that, click into the find online material, and then click here, and then you get two parts: theory on trigonometric equations, and you will find my lecture here. Okay, it is me who you are seeing, and this is my classroom in my home actually. And you will find that I recorded this one. You can look into it, and there are two parts. You can look into it first, that a trigonometric equation. This is one thing. And then again you come to the right practice test. Then click here, inverse inverse trigonometric functions. Click on the find online material, and you will find there are 10 lectures, but I will suggest you go from the top as many as you can, because when you will discuss tomorrow about the complex number topic, while you will discuss the argument or amplitude, they are the fundamental knowledge of inverse trigonometric functions is required. So it is important that before you start our class tomorrow, you look into it today. And this is the way to look into it. First you will get inverse trigonometric functions, the fundamentals I explained in details, and then how it goes with the inverse trigonometric functions part 2, how we define, and then part 3 I define, part 4 you go as many as you can. So with this, dear students, I would like to conclude the class for today. And if you have any question, never hesitate to ask me about it. Um, and tomorrow we will have our class at 9 o'clock in the morning.
Yes.
Thank you very much. All right.